Wafer chocolate bars are one of the most satisfying snacks in the candy world, combining crisp, airy layers with smooth chocolate in a way that feels light but delivers a powerful crunch. Yet behind every bite is a high-speed food engineering system designed to produce perfect wafers, flawless cream layers, and glossy chocolate coatings by the millions. What seems like a simple candy bar is actually the result of precision baking, humidity control, chocolate chemistry, automated layering systems, and non-stop packaging lines operating at incredible speed. And today on the How Factory, we're going inside a modern wafer chocolate bar factory to see exactly how these crunchy candy bars are made from raw ingredients to finished wrappers ready for global shelves. Wafers have a surprisingly long history. Thin-baked wafer sheets were made in Europe centuries ago using simple irons, often served as delicate treats long before modern chocolate bars existed. As industrial baking evolved in the 19th and 20th centuries, wafer production became mechanized, allowing factories to make uniform sheets at massive scale. When chocolate coating technology advanced, wafers became the perfect structure for a candy bar. Light, crisp layers that stay crunchy under chocolate, creating a texture that solid chocolate alone can't match. Today, wafer bars are engineered for consistency, shelf life, and crunch stability across global distribution. The modern process begins with ingredients arriving in bulk. For wafers, the main ingredients are wheat flour, water, vegetable oil, sugar, emulsifiers, and leavening agents. For the cream filling, factories use sugar, fats, cocoa powder, or milk solids depending on flavor, and stabilizers that keep the filling smooth and spreadable. For the coating, chocolate arrives as blocks, chips, or liquid mass containing cocoa solids, cocoa butter, sugar, and milk powder. Each ingredient is tested for moisture content, particle size, purity, and flavor strength, because small variations can affect crispness, texture, or flow in high-speed systems. Production starts with wafer batter, which is very different from cake batter. Wafer batter is thin, almost like heavy cream, designed to spread quickly and bake into a crisp sheet. In large stainless steel mixing tanks, flour and dry ingredients are blended first to prevent clumping. Water is added gradually while high-speed mixers create a smooth, lump-free liquid. Oils and emulsifiers are added to control batter flow and help release wafers cleanly from baking plates. Sensors monitor viscosity and temperature continuously, because batter consistency determines wafer thickness and final crunch. From mixing tanks, batter is pumped into wafer baking machines, massive, continuous ovens built around rows of heated baking plates. These plates open and close like clamshells. A precise amount of batter is deposited onto each plate, then pressed shut. Within seconds, the batter spreads into a thin layer and bakes. The plates move through heated zones where temperature is tightly controlled. Too hot and wafers burn or warp. Too cool and they remain soft. Baking times are short, but the system is relentless, producing wafer sheets non-stop. When the plates open, wafer sheets release onto conveyors. At this stage, wafers are extremely delicate and must be handled gently. The factory environment here is controlled for humidity because moisture is the enemy of crunch. Even slightly humid air can soften wafers, destroying texture. That's why wafer production rooms often feel dry and warm, with strong ventilation systems keeping conditions stable. Fresh wafers are still warm and must cool before layering. Cooling conveyors carry sheets through controlled airflow tunnels. If cooling happens too quickly, wafers can crack. Too slowly, moisture can condense. Cooling is engineered to stabilize structure while preserving crispness. While wafers cool, the cream filling is produced. This filling is not like cake frosting. It is a fat-based, shelf-stable paste designed to stay smooth without refrigeration. In large mixers, sugar is blended with fats and flavor components. For chocolate wafer bars, cocoa powder may be added, while vanilla or hazelnut flavors are used for other types. The filling must be spreadable but firm enough to hold layers together. Mixing generates heat, so temperature control is critical. If too warm, the filling becomes oily and unstable. If too cool, it becomes stiff and difficult to spread evenly. Once wafers and filling are ready, the process moves to layering, where the candy bar structure is built. Wafer sheets enter automated assembly lines. Spreading machines apply a precise, even layer of cream onto a wafer sheet using rollers or doctor blades. Another wafer sheet is placed on top, and the process repeats, building a stacked block with multiple wafer and cream layers. The number of layers depends on the product, but consistency is essential. If the cream is too thick in one area, the bar becomes uneven. If too thin, layers won't bond properly. As the wafer block grows, it is pressed gently to remove air gaps and create uniform thickness. The block then enters a conditioning zone where it rests briefly. This allows the cream to settle and bind layers together. During this stage, humidity control is still critical to prevent wafers from absorbing moisture. Once stabilized, the large wafer slab moves to cutting. High-speed guillotine cutters or rotary blades slice the slab into long bars, then cut those into individual pieces. Cutting must be clean and precise. Wafers are brittle, so blades must be razor-sharp and perfectly aligned to avoid crushing edges. Broken pieces are collected and often reused in other products or as ingredients for confectionery fillings. Now the bars are ready for chocolate coating, the stage that turns wafer stacks into true candy bars. Chocolate handling is a science of its own. Chocolate must be melted and conditioned to flow smoothly while maintaining its final snap and shine. In large melting tanks, chocolate is heated gently and pumped through tempering machines. Tempering controls the crystallization of cocoa butter. If tempering is incorrect, chocolate will appear dull, develop white fat bloom, or melt too easily. Tempered chocolate flows into enrobing machines where bars pass through curtains of chocolate. The chocolate coats the top, sides, and bottom in one continuous motion. Excess chocolate is removed using vibrating conveyors and air knives, ensuring a smooth, even shell. Some bars receive decorative drizzles or textured finishes at this stage. Coating thickness must be consistent. Too thick wastes chocolate and changes bite. Too thin reduces protection and snap. After enrobing, bars enter cooling tunnels. These tunnels are long, temperature-controlled chambers where chocolate solidifies gradually. Cooling must be carefully tuned. Rapid cooling can cause cracking or unstable crystal formation. Slow cooling can lead to bloom or soft shells. The goal is a firm, glossy coating that locks in crunch and protects wafers from humidity. Once cooled, the bars undergo inspection. Optical scanners check shape, coating coverage, surface defects, and alignment. Weight sensors verify correct chocolate thickness and bar size. Any defective bars are rejected automatically. Samples are taken for bite testing, ensuring the signature crunch is present and layers break cleanly. Packaging is the final high-speed stage. Wafer bars are extremely sensitive to moisture and oxygen, so packaging must create a strong barrier. Wrapping machines feed printed film around each bar, sealing it tightly. At full speed, these machines can wrap hundreds of bars per minute. Date codes and batch numbers are printed for traceability. Wrapped bars are grouped into multi-packs or cartons by automated packers. Cartons are sealed and palletized using robotic systems. Finished pallets move into warehouses where temperature and humidity are controlled to protect chocolate and crispness during storage. Behind the scenes, sanitation and quality control run non-stop. Candy factories operate under strict hygiene standards because sugar and fats attract pests and spoil quickly if contaminated. Equipment is cleaned frequently, especially in filling and chocolate systems. Air filtration and controlled access zones help protect production areas. Sustainability also matters in modern confectionery plants. Wafer scraps and chocolate overflow are recycled into other products. Energy recovery systems reuse heat from ovens and cooling systems. Packaging designs are optimized to reduce waste while maintaining freshness. What makes wafer chocolate bar production remarkable is the balance between fragility and speed. Wafers must remain crisp, chocolate must remain perfectly tempered, and layers must stay aligned, all while machines run non-stop at industrial scale. Even small changes in humidity, temperature, or ingredient consistency can affect crunch, coating quality, and shelf life. From thin batter poured onto hot plates to stacked wafers bonded with cream, from glossy chocolate enrobing to high-speed wrapping lines, The journey of a wafer chocolate bar is a synchronized system built to deliver the same crunch in every bite, anywhere in the world. And that is exactly how wafer chocolate bars are baked: layered, cut, coated, cooled, inspected, wrapped, and shipped, transforming flour, sugar, and cocoa into crunchy candy bars produced by the millions. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machines, ingredients, and factories behind the snacks we love.